Well, ionic bonding has to do with what other word do you think of when you look at ions? Yes. So remember, whatever I write on the board, you write in your book. Ions. So when we're talking about ions, what are the two different ions?
Catatonic and anion.
Cation and anion. I like the little way that you have it there. I might use that. I might be saying it wrong, so we're okay. So a cation, what do we draw for a cation?
Plus a paw.
A cat paw. There you go. Because it is positive. Does it donate or receive?
Yeah, donate.
Donate.
And then for the anion, you draw little antennas on the little ends.
Yep. And it is a
negative.
and it
receives.
All right.
It kind of like Scrooge and Chris.
So here we are. We have this. Coming back to our memory again. Here we go again. Let's see if you know what this is.
Oh, that's the thing with the dots.
That's the Lewis model.
Nope.
No, that's
Lewis
the
model.
Bohr model.
Yeah.
Okay. So Bohr model is what we're going to do. Coming back to that again. Hallelujah, right? So if lithium, okay, actually would go in with fluorine, if I drew fluorine, how many energy levels do I have?
You said lithium fluoride?
Oh, wait, yeah, I just said fluorine.
Fluorine. You got one of or two of them.
2 energy levels. Thank you, sir. First energy level, what do I have? How many dots?
You got 8 of them.
I got 2 dots on the inner one. Then I have 7. 1, 2, 3, 4, 5, 6, 7.
Because it's a halogen.
How many does fluorine want?
One of them. So it bonds with one of them.
It don't even bond, baby. It actually goes here, and that electron goes out, and now they are happy. Are you ready?
I thought lithium would have 8 on the inner one, though. Because ain't that why it wants to give one away?
Well, remember lithium, hydrogen, and helium, the ones that are on the first 2 rows, they can do with 2. But you're exactly right. I like that. Can't have 8 if it doesn't have 8 in it to start with, because there's only 3. Okay? So that's one way of illustrating ionic bonding. The other way is where you do what's called the crisscross method. Are you ready? So if we're doing Li and F, right? We know that Li has a positive 1 charge, right? We know fluorine has a negative 1 charge. What we do is we take the charge and we put it down as a subscript. Okay? So that is LIF. Bless you. Everybody good so far? Let's do one a little bit more complicated. Okay? Let's do the Bohr method. And I would like you to do Mg and S. So the first thing I want you to do in your ISM book, I want you to draw me the Bohr method for both of those, show how it donates and receives, and then do the crisscross for me. You got this.
I get some wood.
Yep. So you're drawing the Bohr method, and you're doing the crisscross, please. water dispenser there, right?
I forget every time. I'll be going. I already been hit it that way. I was like, I'm sorry about this one.
No, you're fine. I just wanted to let you know. We are doing magnesium and sulfur. We're doing the Bohr method, and then we're going to do the crisscross method to see what we've got.
So,
M and G and S. Yes.
and then you said so.
Yep.
Don't forget.
Mm-hmm.
So,
Alrighty.
but
So-
magnesium ain't got the 2 valence electrons, right?
Correct. So the first thing we want to look at is how many energy levels do we have for magnesium? Well, Mg has 1, 2, and 3, 2, 8, and 2. Correct, you guys? And then if we took a sulfur, we have 3 energy levels. We have 2, 8, and 6, correct? So what happens is these 2 will come over here and donate it to make this 8. This will go down, and it has 8. And if we do the crisscross method, which is Mg plus 2, S plus 2, then my answer is MgS. Is that what you did?
I believe so.
Okay, so hold on. How do you get the +2?
Well, here's the thing. When we're talking about cations and anions, right? So if you start over there on the periodic table, you have +1, +2, +3, plus and minus 4, -3, -2, -1, no charge. So what you do is you have to look at the periodic table to figure that out. All right, are we ready? Let's do this one. Do a hard one. Okay. Let's do oxygen. And let's do hydrogen. Because you know this one.
Water, right?
Yep, you know this one, but it's going to show you why. Okay, so do hydrogen and oxygen, do the Bohr method, and then do the crisscross method on the bottom for me. This is a trick question. The one thing you're going to do with this, with the ionic bond, this cannot happen. Can't. Reason it is, you got a +1 and a -2, right?
Yes, right.
Okay. So if we did that, then that would be H2O, which we see, right? But hydrogen could not donate its electron, could it?
No.
So this is an example of a covalent
I heard that word.
bond, okay, where they share stuff. But we're not going to do covalent. We're only doing ionic today. Does everybody understand so far? One key thing that I have not given you is what? It has to be, an ionic bond has to be between a metal and a non-metal. How do we know what a metal and a non-metal is? Periodic table.
Ain't that how a lot of different if they like something else?
Well, here's what we have. We have what's called a stair step. You see where boron is? So what it does is it starts with boron first, goes over to silicon, and it keeps going down. Metals and non-metals is what we have. So one has to be on one side, one has to be on the other.
I thought the majority of these here in the middle was metals.
They're transitional metals, correct?
But like there's copper and zinc and So that like go.
They're metal. Yes.
I don't know.
Nitrogen, is that a metal?
No, nitrogen.
It's a gas, right? Non-metal.
Oh, okay. So everything on this side is non-metal.
Everything on that side is a metal, on this side is a non-metal. And there's a stair step that goes through, and you'll see it on your periodic table that shows.
Okay.
Okay? All right, so we're going to get up. We're going to go back to the back because God knows you need it. Let's go. You need to bring nothing. We've been standing long enough.